Hello, everyone. Welcome to the webinar one of the Data Science, Machine Learning, and AI Applications and Opportunities webinar series. We all agree that data science, machine learning, and artificial intelligence will continue to transform human lives in the 21st century, and we are already seeing an onset of a lot of applications of AI, machine learning in everyday life. But whether that transformation will be for good or ill or both relies heavily on the decisions made by the humans. One of the decisions that I have made is to educate and nurture the next generation leaders in the field of data science, machine learning, and AI. I am Rahul Rai, Dean's Distinguished Professor at Clemson University, and my primary research thrust is in the application and development of novel data science, machine learning, and AI techniques for various engineering applications. And despite the exponential growth I see in the application of machine learning, AI, to a wide variety of engineering and science problems, I have heard from many stakeholders, such as students, industry professionals, that there needs to be a lot done with respect to building and connecting a cohesive community of engineers who are interested in the domain of data science, machine learning, and AI. We also see an onset of job requirements. We also see an onset of many openings in the field of AI and data science. And there is right now also a lack of right skill, or there needs to be upskilling of current generation of industry professionals with respect to AI machine learning. So in that context, building a community becomes even more important to address this skill gap. Now, this webinar series is essentially an outreach activity focused on building this community, and that's why we are here together. So once again, welcome everyone, and I sincerely thank you for participating in this overall webinar series. So we will get started, and I will start with sharing the slide that we have. So the focus we have in today's webinar is basically on industry, research lab, and academia. And the way I'm trying to organize this webinar series is we will have different participants coming from industry, research lab, and academia in different webinars. And today we have essentially a medley of people from academia, industry, and research lab talking about applications of machine learning and AI. What I want to do is, before I introduce the panelists who are going to talk about some of the applications that they have, I want to take basically a small time to also make an advertisement for the next webinar, and remind you that we will be having this webinar series every Thursday at 11 a.m. EST. And for the next webinar series, we are going to mainly focus on manufacturing and applications of data science and AI and machine learning in manufacturing domain. And this topic, subtopics for this webinar series is manufacturing analytics. And we will have Dr. Thorsten West from West Virginia, Dr. Yinglu for Cardiff University, and Dr. Satish Bukapatnam from Texas A&M University presenting their work in the domain of manufacturing analytics. So with that announcement, what I want to do is I want to focus on today's talk and today's panelist. And the first thing that I want to do is introduce today's panelist and give some brief background about it. So the first panelist that we have is Abi Seth. Abhi is an experienced data and analytics leader with track record of successfully establishing analytics team ground up in large multinational organizations. And he participates in driving a culture change that leads to monetizing analytics services and delivering tangible value across multiple business areas. He is passionate about driving an enterprise culture with a strong focus on the talent development and enabling a cross-functional analytics operating model that delivers success at scale. Currently, Abhi is the Vice President of Data and Analytics at TE Connectivity, world's leading electronics connector and sensor manufacturer. At TE, Abhi leads the global data insights and analytics team. His key responsibilities include champion top-line growth and margin expansion through strategic use of enterprise data, modernize enterprise architecture, and establishing governance and data stewardship. Prior to joining TE, Abhi also held senior leadership positions in Honeywell International and at Caterpillar in the area of analytics, business, and strategy. So let's welcome Abhi. And the second panelist that we have in this panel is Jinmiao Huang, who is currently staff AI research scientist at LG Electronics AI Lab in Toronto, Canada. She's working on improving the performance of user-defined keyword spotting and managing the transition from point of contact to product. Before joining LG, Jinmao was computer vision research scientist at ABB Corporate Research Center in Connecticut, USA. So with that, we welcome both the panelists. And today I will be basically having two hats. One is moderating this session, and I will also act as a panelist and present some of the research work that we have done in our lab. And the setting for this webinars is essentially each panels will be presenting and talking about the applications that they are working on. And then towards the end, I will have some questions with regard, which I will ask to the panelists, and then we will follow up with question and answer sessions with the live audience. So if you have any questions that you have that comes to your mind, please post those questions so that we towards the end of we can address some of the questions. So with that, let me welcome Abhi to basically talk about his research. So I will stop sharing and I will pass on the handle to Abhi for his set of presentation.
Okay, thank you. I think you need to probably enable me to share my screen.
There you go.
Okay, hold on. Coming up. There you go. Perfect. It's working now. And are you guys able to see my screen?
Not yet.
Is it working now or no?
Not yet.
Okay, let me see. Share.
Yes, started to. Yes, now we can see it.
Okay, perfect. So, awesome. Okay, hey, thank you so much for the kind introduction, Rahul, and kind words. My name is Abi Seth, and I lead the data science and insights practice at TE Connectivity. I'm not sure how many of you guys know TE Connectivity. I'm going to talk quickly about who we are and what we do and what is our mission, and then I'm going to get into a few different examples on how we have applied machine learning. There is a lot to talk about on this exciting and meaty subject, I would say. And with the limited time, I'll talk a little bit about what kind of problems are we solving at TE? What's the value we are creating, and then how is it driving transformational change for our business overall? So just a little bit about TE. Let me see if I can put it in this presentation mode. Perfect. So for those of you who don't know about TE, we are basically a $12.5 billion electronics manufacturing firm with global presence in around 140 plus countries, 82,000 employees, and a heavy spend in engineering, I would say, in R&D. And our applications for the products we make, basically we make around 192 billion products annually, which is a huge number. And they go in all kinds of applications and products that almost everybody uses on a daily basis, all the way from your data centers to your computers, to your cars, industrial equipment, transportation sensors, all the way to your airplanes or your coffee maker, has a TE connectivity connector or a part in it. But it's kind of hidden. So a lot of people don't realize they're our customers and they're consumers of the parts. We are an industry, leader in technology, innovation, and engineering in the industrial domain. What you will see, basically, it's a highly admired company in terms of recognized to be top global innovator. By Fast Company, we are recognized as best place to work for innovators. And then, we just got this recognition last week that I'm most proud of. It's really the best employers for new grads. So. Really an exciting place to work with, a highly global company with a very collaborative culture and focus on how do we deliver shareholder and customer value, right? So part of my discussion is basically, can you guys see the screen, or do you see this this logo on the top from Zoom? Are you guys able to see the title of this chart or not?
Yes, we can see the title of the chart.
Okay, so there is a ribbon on my screen. Maybe that, glad that you're not seeing that. So this really just talks a little bit about, before we get into machine learning, right? I think we talk about how the whole analytics word is kind of framed. And I've only put one intro slide around it, which is basically, a lot of companies are focused on, in terms of data driving business outcomes, right? And I think that's kind of where all of us want to be, in terms of how mature you are and how effective you are in leveraging the data for your day-to-day decision making. A lot of the companies are really, the basic, you got to get the basics right. It's like, how fast are you going? If you want to be a NASCAR driver, you must have a speedometer, right? If you're tuning a car engine, you must know how fast you're going and what's your acceleration. So that's really your descriptive diagnostic analytics, right? Which is all about where you are, how are you performing against certain set of targets, what has happened, and then the challenging thing about it, what has happened, can you tell it a month ago, a week ago, a second ago, right? That's where it becomes challenging. Descriptive doesn't mean it's easy. And then how actionable it is, what do you do about it, right? And then diagnostic, if something doesn't happen because you did not meet your KPI or you did not achieve the result you were hoping to, why? And then it's also, I think both of these things are really looking at past performance, right? But ultimately where we really want to go drive analytics outcomes is really more, how can we become more mature in driving analytics to be more predictive, prescriptive, optimization, cognitive. And I think what these things are all about is how do you drive future decision making to be more effective, right? And that's where advanced analytics techniques like machine learning, streaming analytics, text mining, deep learning, optimization kind of techniques come into. And what this is about is really looking at what's going to happen next. Is this trend going to continue? So like the big question last year was, how deep, how long is this downturn, and when the next upturn is coming to be. And then now the question from a lot of the general managers in the market is, we are seeing a huge demand, is this going to sustain? Think about housing market, think about auto market, or when is it going to peak and then become normalized again? Is it a 6-month peak or is it a 2-year peak? Because people need to prepare for it differently. And in terms of so that's kind of predictive. When you get into prescriptive, is basically if something is going to happen, you predict something, then you also provide a recommendation on what do you do about it. For example, in my past life in aerospace, we were predicting which part on a aircraft is going to fail within the next 3 to 5 days, which is going to create a delay or a cancellation for an airline. But that was not good enough. We have to say, hey, there is this much probability of this part failing, and here is the maintenance procedure that you need to follow. Here is the part you need. Here is the process you need to go fix the aircraft. So it's really more of a prescriptive recommendation, not just a predictive recommendation. And then optimization really gets into, optimizing and, under against a certain outcomes. I'm sure all of you guys have done optimization, right? So this is really around KPI dashboards, trackers. And I think some of these examples that I'm talking about is some things, I just picked a couple examples from what we have done in TE. For example, forecasting revenue, uptrend, downtrend, forecasting which customer is going to churn, right? Forecasting, if somebody buys this part, or predicting somebody buys this part or interested in this part, what other part are they going to buy? All of us have experience on Amazon, for example, or safety stock. Okay, you don't want stock outs. How much safety stock do you keep so that when the demand goes up, you can still continue to provide to customers. Okay, so I think this is kind of one of the ways. And to enable any of it, I think really the ultimate point is you must need trusted and governed data and a scalable architecture if you're going to drive outcomes. Because if you can't trust your data, if you can't find your data, if you can't trust it, you can't do any even a proof of concept, right, with a good degree of confidence. And in order to scale or apply it across multiple BUs, run these analytics in real time, you have to have a platform on which you can deploy these analytics and maturity around how do you productionize. So I'm going to walk through 3 different examples that I just picked quickly. So revenue forecasting, when 2 years ago, this was a big problem, so in STE connectivity, we sell directly to customers and we sell also a big chunk through our distributors, right? So as we look at our distributor sales, they are they are a big number. Basically, a large portion of our sales are distributed sales, and every business unit, we have 10 business units. So every business unit has to predict what is their revenue going to be by end of the year. And they know with a high level of confidence their direct customers, but they kind of don't know with a high level of confidence how much are distributed sales going to be. And a lot of times in the second half of the year, if the distributed sales aren't materializing, that can have a big impact on their revenue number that they were planning to. So they can have inaccurate capacity planning, they can have inventory challenges, they can have OI is operating income. So they basically can't meet their commitment to the market around here is the profit per share we are going to deliver, here is the margin we are going to deliver. And in the last 2 quarters, if you only have 6 months or 4 months to go chase that, it's not possible to address that situation. So this becomes a very difficult problem globally. So one of the objectives was basically, can you forecast what my channel revenue going to be with at least 90% accuracy by business unit, by region. Okay, so that's the challenge that was given to us. What we did was basically within 9 weeks, we basically used the historical sales for channel, um, distributed sales for the last, so from October 15 to 19, 4 years worth of data. We also looked at which industries we are selling it. We went to Bloomberg, Trading Economics, and several other places to identify what are the external economic indicators. We tried 4 different models, the VR model, ARIMA, Profit, DPAR, on seeing, okay, how can we basically, and at what level do we break down so that we can get uh, better forecast accuracy. So we ran this and basically integrated the economic indicators for each business unit and region into the trends and seasonality into the models. We built and trained basically models on a 16-quarter history and tested the models and basically selected Profit and ARIMA as the 2 models that worked for us. So ARIMA worked for short-term forecast, has a higher accuracy, and Profit has a higher accuracy for forecast that's 3 to 4 months out. So I'm assuming you guys know about Profit. That's a model Facebook invented and open sourced. That's kind of something we use. ARIMA is basically a classical model that's been around for a while, but it's really how you take internal and external indicators to and do feature engineering so that you can actually get better results. That's kind of where majority of the magic is around it. But the exciting part is basically the model, we launched it in January of 2020, and we did not know how it was going to perform. And then COVID hit after that. But looking at it, the model has actually delivered more than 90% forecast accuracy throughout COVID. Even though it was not trained on an event like COVID, it was able to predict revenue with more than 90% accuracy. So the businesses came to us probably sometime in September, October, that your model is showing a huge ramp up in December. Are you sure about this? Because we are seeing a huge decline. And we talked about it. They were able to basically understand, be more aware of the market swings, and be better prepared for both the downturn and the upturn throughout COVID. So this is kind of a very powerful story on how analytics help the business drive something. The second one is around customer churn, right? So if this is a problem every company has. A lot of customers come in, some customers have bad experiences, or we are not able to provide products, or they just moved on to a different market or different product, and then they kind of churn out, right? So their revenue drop and they are no longer a customer. So it was last year very difficult to track effectively and even prevent churning. As a result of that, basically several $1 million of revenue was getting impacted for TE. So one of the objectives of this project was, can you predict with a high degree of confidence which customer is going to churn, and also tell me why are they going to churn? So is it a quality issue? Is it a not we are not able to deliver them the parts? Is the price too high? Or is there some other issue because of which they are churning, right? So predict to me who's going to churn, why are they going to churn, and then present the insights to the sales and the account teams in a very accurate and actionable way, so that they can actually go take some action around it, right? So that's something we did in 12 weeks, where we looked at, we defined what churn is, right? So it's really a customer plus part number. So it's not just a customer. Basically, a customer buying $100 a year of this part, now suddenly they start buying less than $50 a year on the same part for the same customer. It means they're reducing the demand and about to churn. So that's kind of how we defined it. It's a classification model, more of a, random forest application with a lot of feature engineering. But we looked at, the last several years of customer part number sales histories. We looked at, um, revenue lost customers. We are looking at different strategies, right? Backward looking as end customer focus. We are looking at recovering high churn products. How can we basically, if some products are having a high churn, is the product having an issue, is the placement wrong, is the pricing wrong, how do we look at competitive threats? And then overall, how can we drive, address the customer dissatisfaction that we are having because of which they are churning? So the model is able to basically provide for high risk customers with more than 85% accuracy who's going to churn, right? And I think that's an exciting claim that we made when we launched the model. But a lot of these things, there is a huge business change management. When you come to industry, you realize just because we built the model doesn't mean everybody's going to believe it and start acting upon it. It takes time for people to start believing it, right? And we presented the model. They were like, hey, this is a model which is still learning, looks promising, let's go use it, see what happens. And then suddenly the model started predicting things where, hey, this customer is going to churn, where the sales team is like, I don't think there is any revenue decline, so why do you predict that? And then once they go find out, they actually realize the customer has moved on to something different. And they were very impressed that the model in multiple of those occasions identified churn that our account and sales team thought it's a healthy customer and nothing is happening there. But we were able to actually proactively identify and understand that and prevent loss. So it resulted in basically several $1 million of revenue loss prevention on the books, I can say, within the first 6 months of 2021. So phenomenal success story, and highly adopted within global sales teams and account teams. And now it's actually getting scaled across multiple different business units. So that's a pretty phenomenal success story for TE on how analytics is driving outcomes. I'm going to quickly cover the third one, which is around safety stock optimization. So think about, as the market is going up and down, right? There is a certain amount of safety stock. So safety stock is a stock, let's say you want to keep in your warehouse. So you want to say, hey, my demand varies from 50 to 150. I'm going to keep 100 units. I'm just making this up again, 100 units. But suddenly, if the demand falls to like 25 units, now you have 75 units extra that you are carrying over a period of time, which is a lot of cost to carry inventory. Or if you start decreasing inventory, or the market goes to like 250 units suddenly because, with COVID, the demand went skyrocketing. And now you are in a very big stock out situation and you're not able to meet customer commitment in terms of being able to deliver the product when it's needed. So how do you really make sure that you're keeping and adjusting your safety stock in a dynamic way and not every 6 months? Because the markets are changing a lot faster, right? So how can you look at demand patterns and then adjust your safety stock so that you are able to meet customer demand 95% of the time? So the goal is increase the service level, which is basically on-time delivery of parts more than 95% of the time, at each part and plant level. So when you think about part and plant combination, there are several, I would say tens of thousands of combinations when it comes to part plant. So it's very difficult to do manually, right? And at the same time, the goal is to reduce the overall safety stock down by 10%. So the point is reduce the inventory, but increase the service level. So you're able to meet the demand much more frequently, but with a lower overall inventory level, right? So that's a challenge. The way we solved it is basically we looked at weekly average demand historically and in the future, and then we looked at demand probability, right? And then replenishment lead time, which is basically how much time. The other thing that's it's dependent upon is basically your variability in your demand, as well as variability in your suppliers being able to supply you product. Because if you don't get the raw material on time, or if some raw material is constrained, you're not able to, you know, build the part and being able to even create safety stock. So as your replenishment lead time, which is basically your service time from your suppliers changing, how can you dynamically adjust that? How can you dynamically look at your weekly demand? And then basically we took multiple of these parameters and did more of a Monte Carlo simulation. So which created basically your demand can be a skewed distribution, right? So when you do a Monte Carlo simulation, you're creating a normalized distribution with more likelihood of scenarios, in terms of over 52 weeks. You have 500 things to pick from. and that you feed in your Bayesian optimization model, which basically picks out what is the right point in time and the quantity at which you need to reorder, so that you can dynamically adjust your safety stock, and not do stock outs. So by doing that, we were able to actually save, um, and I can't talk about numbers, but several $million in benefits to the team. We are able to actually improve the safety stock levels to basically be down, as well as at the same time we were able to actually increase our service levels to be up. So that's a pretty big service success story. Um, and we are now basically did it for finished goods. Now we are doing it for raw material, and then taking it across multiple business units as we speak. So some examples on how analytics is creating value for industry, and that's kind of where I would end it. And if you have any questions, I'm happy to share. Sorry, one more slide I forgot to share, which is around, if you guys can see my screen, we have, if you are interested in any of these analytics projects, we have internship and full-time roles available within TE. James basically is the right person to contact, or you're welcome to reach out to me for internship opportunities for 22, or full-time opportunities for 21. So that's all I have. Rahul?
Thank you, Abhi. Thank you very much for presenting three very nice application areas. I hope this would be relevant to some of the participants here. With that, we will move on to the next panelist, which is Jinmiao Vic Huang's. Vic, can you share your screen, please?
Sure. Thanks, Rahul. Just give me 1 second.
And for all the participants, I will, I will ask you to basically place your questions in the Q&As, which we can collect and ask the panelists the questions later on. So you can specify the panelist to whom you want to ask the question, and then type in the question, and then I will basically ask that question to the panelist. Thank you.
So I'll get started. Today I'm going to talk about applied AI research, typically in LG. So I'm a staff AI research scientist in LG Electronics, Toronto AI Lab. So let's start by giving you a general idea what is this LG's business. So basically, you probably know that we have home appliance and air solutions with those, say, fridge and dryers, air conditioners, and there's a cleaning robot. And we have home entertainment, that is TV and soundbar. And we also have mobile and vehicle solutions that is like hardware inside the vehicle. And currently, there are teams, they are building simulators for self-driving cars. And there are other business-related solutions like monitors and laptops. So in terms of AI, let's say, so AI is actually building into different products. For example, this one's guide robot in the air, I think in Korea airport. So this one, it's involved like natural language processing or computer vision and audio processing. It's all built into this robot. And this one, ThinQ Fit, so we'll be able to fit different outfit with our target customer. And as you can see, probably this is a computer vision, mostly computer vision related in the AR, VR related project. And this one, fridge, so it has a recognition system inside, so tells you what is inside your fridge, and also have a recommendation systems that recommend you, oh, probably you would want to restock some of the items, and also have a conversational panel so that you can interact with the fridge. Okay. So I categorize these different applied fields of AI in LG. For example, natural language processing, speech recognition, computer vision, robotics. That's basically like generally like control system, even the control system inside of a washer that they want to use reinforcement learning to learn how to control the washer to balance the load inside so that you can optimize the energy usage, and machine learning like data analytics problems. In terms of Toronto AI Lab, we do natural language processing, speech recognition, and computer vision projects mostly. And I'm responsible for this speech recognition. So I'm gonna give you detailed example of how we develop this user-defined keyword spotting, because this one is recently published in ICAST 2021. So I can share some of the details of how we develop this model, and hopefully hope you have a better idea of how we develop things inside of LG. Okay. Let's start by give the problem from formulation, and I talk about model, and then talk about results, and finally conclusion. So for the problem formulation, this one will focus on user-defined keyword spotting. As you know, for example, Alexa, for example, Siri, those ones are predefined keyword spotting that you awake your smart device. And for user-defined keyword spotting, the model, the pipeline we're gonna use is we need the speaker to enroll their voice with a particular keyword for 3 times, for example. And then we have this function, usually a deep learning model. And after this function, it transfers the signal into embedding space, into a smaller embedding space. And in the query time, so in the runtime, when you like speak this certain keyword, and by using this neural network, you'll be able to transfer this query into the same embedding space. So then you compare the distance between this embedding space. So if the distance is say is lower than the threshold, we say, okay, those are the match. If it's not, then it's not a keyword. Basically, you can consider this as a template matching problem. And okay. Another thing I forgot to mention, that we need to develop this model so that we can run this model into a small memory footprint and with low latency. So I just quickly go over the model that we have here. So for example, the input, as you know, it's a waveform, it's an audio sound. And we use FBank to transfer this high dimensional data into a lower dimension so that it can be better learned from the neural network. So this neural network is something we developed. So there are different layers of RNN layers, and there's attention layer, and there's additional attention layer. So if you are interested, I can share the paper's link with you so you know what's inside of a different module. Because of time, I just skip those parts. And okay. Yeah, so like this one, for example, is attention layer. So if you are familiar with transformer, You know, this one is pretty much similar to the transformer attention component. And another component is it's one that we developed internally. And we use this normalized version of multi-head attention aggregation to better aggregate the information. Okay. And the result part, as you can see, we have a very small model developed and a slightly larger model developed that to target for different products inside of LG. And in terms of hyperparameter tooling, we use ASHA hyperparameter search method to automatically search the parameters for us. And as you can see, this in academia, you might use some open public data set to evaluate your model. And inside of this company development, we use internal data in terms of a publishing paper. We also try to use on a public data set. And so for example, we have an internal goal. Internal KPI says, okay, we want this false alarm rate to be 0.3, and false rejection rate should be less than 0.01 or 0.02, something like that. This graph just to show how the model performed, and in terms of KPI, it achieves the KPI goal. And this is a comparison with our model with baseline model in a public space. So in the company, we usually start by using some baseline model that's available in the research community, and start using that and try to improve the accuracy based on that model. So ablation study on different components, how it make a attribute to the model performance. Yep, so thank you. If you have any questions, just let me know.
Thank you very much, Jinmiao, for presenting what your group at LG is doing at Toronto, and in general, the LG is doing in terms of application of machine learning and AI. So, this brings us to the next part of the webinar, where I have a set of questions that I'm going to ask the panelists, which is Abhi and Jen. And those questions are very generic questions and mainly geared towards the main community that we are trying to build. So first question that I have for Abhi is, we know that obviously there are many students in this audience who are thinking about their career paths. They're thinking about having a career in data science and machine learning. And I think if you tell them a bit more about your journey and how you arrived at your current job, which is focused on data analytics and machine learning, that might help them. So can you please share your journey so far, Abhi?
Yeah, happy to. I think I kind of found myself into analytics because, early in my career, I kind of was always oriented towards more applied research versus basic research. When I got through PhD, my PhD was in virtual reality, augmented reality, and physics-based modeling, and was leading a research group. Want to go be a professor. So I always admired you, Rahul. Right? I think if we, looking back, got into industry because I wanted to prove out what's the value of research, right? How do you quantify it in dollars and cents, and really actually being able to make some quantifiable impact, right? Or like kind of a ding, right? In terms of what the outcome is, and be proud of, hey, I did this. And so I got into Caterpillar, starting out as a VR researcher. And then ultimately, within a few years, took the PhD out of the equation and doing a virtual reality design review. So really democratize an early technology that, back in 2007, 8, it was more of a research technology, still is researchy technology, but really how do you democratize it so that everybody can use it? So people can use file, open, load their model, and then again, sit in a machine that has not been built before, right? And that's kind of what Caterpillar did in 2008 to onwards, and everybody globally started using it. Then I got into analytics. I got into strategy because I got bored doing R&D. Then I got into strategy. So strategy is where which is very complex and challenging, but I think data is the only beacon you have when you are doing strategy, because otherwise it's opinion. Right? And you're making some really big transformative decisions which have a huge multi-million, if not multi-billion-dollar financial impact on the company. So I started using data, and that's kind of how I got into analytics. But I had a knack on complex problem solving, simulations. I was comfortable with math and programming, if you will, and had some statistics background, and got into analytics. But then really it's more about how do you drive analytics and these technologies to drive outcomes and problem solving. So it's really, I've done work in taking analytics products to end markets. How do you sell those analytics products once you build them? Like I gave you an example of the connected aircraft at Honeywell, on predicting machine failure, component failure on an aircraft, or doing so in Caterpillar for mining trucks, or doing it internally that I just talked about. So that's kind of how I stumbled into analytics, and the focus on my passion is about are we solving the right problem, because it's we have so many smart people, we can always solve the problem. I think it's really where I see the challenge is, are we solving the right problem? Did we pick the right problem to solve? Because if you can pick the problem which has a big outcome attached to the end, because ultimately analytics is all about driving change management and business decision making. And in domain, once you come into industry, you realize that building the model is the easy part. You can do it in 12 weeks, as I talk about, but getting it implemented takes you 12 to 18 months to driving that last mile adoption, the change. And that's kind of what we have been trying to go focus on, is pick the right problems, make the insights easy to use, give it to the hands of people so that you make the right data-driven thing the easy thing to do. And then people drive outcomes and change, and then you measure the outcomes. The most exciting thing about analytics, and I would encourage everybody, first of all, there's a few things I encourage people to look into analytics as a career. It's one of the most fastest growing careers. You want to go in data engineering or data science or something else, you get to work with the business, because you always don't only ask how are you solving it, always ask why are you solving it, right? That's to me a big satisfaction. And then you get to, it's very few fields that you can connect what you are working on to how does it show up on a profit and loss statement of a company. And you can sometimes, if you're lucky enough, quantify how many cents in an earnings per share at the end market you contributed, right? So to me, that's kind of a really exciting place to be.
Thank you very much, Abhi. Jen, I have one question for you. That you have been in the data science and machine learning field for quite a long. And according to you, what are the main attributes or main skill set that a good data scientist should have?
Yeah, thanks a lot, Rahul. So in my opinion, I always value the fundamental like math, statistics skills. If I'm like interview candidates, it's the most important thing is they do understand those basics. So that's the building blocks that is very important. Although some of the candidates, they probably do not have a speech skills, speech related projects in their background, but that's okay. As long as they have these basics, it's pretty much trainable. So I recommend everyone to really learn how the basics works. And other than the basics of the math and statistics, I think it's also very important to have a strong coding and software development skills, because in the industry setting that we do, most of the time we do not have. We need to just develop. Although I'm a research scientist, I still need to develop those tools to help me to reach my goal. Like my ideas, I have to write it into the code, to see the results. And other things I think is important is the problem-solving skills. So what do I mean by that is, say, when you have a problem, you're gonna have this gist to know what model to use. Is this data good enough, or is a machine learning problem, is a deep learning problem, or is just something not solvable, not solvable at all. It's very common that in the business that people consider deep learning as a black box, so they want to use it for anything, but that's typically not the case. So yeah, so I think tons of different project experience would help you to reach this prediction skill.
Yeah, I think
Thank you.
I like the answer. I think the only thing I would emphasize is really what you mentioned, Jin, is the problem solving skill, right? I think I have seen so many people who are great programmers sometimes, and then can get every certification that's available on their signature, on their resume, but don't know how to think about a problem in terms of true researcher, like a brainstorming. What are the right inputs, right? And what are the right features that I should be engineering so that I can get the right outcome? Because a lot of this magic, I mean, in all seriousness, AI is becoming more automated, right, as the word goes on. So a lot of the skill is really thinking about the problem, asking the right questions from the business, brainstorming what features do you really need to put in. Otherwise, I hate to use this, but sometimes I call, a programmer a juicer operator. It's like, okay, I can put anything in and the juice comes out, but you want to be a chef.
Yeah.
So that's kind of the difference between a good data scientist versus a juicer operator. It's like, okay, anybody can program. How are you thinking about the problem, and what questions do you ask, and then what insights do you bring in, so that you can set up the problem the right way that it can be solved, or at least, if not solved, at least improve the understanding of the problem, right? I think that's really the most important. Not every problem can be solved, to your point, but do we have a better understanding of, after applying 10, 12 week, whatever time frame, that we understand it better. We know what data to collect if we want to in future go and attempt it. So that's the key. And then the last thing is really the learning, right? So always be focused on new learning capability, which I know a lot of students are so good at. So just keep that up, because the field is changing very fast.
Thank you very much, Abhi and Vic. There is one question from the participant attendees. It's a very interesting question. So, Avi, you mentioned that about the trust in data, because if you don't trust in data, then the decisions you are making are probably going to be questionable. So, this question is in relation to that. The question is, okay, we should trust in data, but how do you trust the algorithm so that we can trust the data? Okay, and if it is purely based on the results of an algorithm, do you also rely on any other means to trust the algorithm? If so, how?
Yeah, I think so. As a true researcher, I'm sure Jin can comment on this also, is you got to always look at things as a suspect. It's like a detective. So you look at data, you look at algorithm, but ultimately it's you who's making a call, right? And the responsibility, again, the whole juicer operator chef analogy kind of translates here. This responsibility is on you, because ultimately people should trust you. When I've had data scientists who say, here is the 3 different models and here is their accuracies, Abhi. I've run all 4 models that are available. And my question is, I've not hired you to just run this data to 4 models. I'm asking you, what is your recommendation? What forecast are you going to sign your name on? And that's a very different thing. And when somebody needs to do that, then you need to actually look at the data as a suspect. You need to do a model as a suspect, and you need to really spend time thinking about what is your confidence level on the result that the model is producing, right? And what is how do you do some uncertainty quantification, because there is not, no prediction is 100% accurate, but is it repeatable? Is it explainable, right? And does it make sense, right? So it's really the correlation versus causation. If it's applicable, and it's not always applicable, right? If you're doing mechanical failure prediction, you must know that, hey, just because the steering wheel is breaking and the brake fluid is, brake is failing, oh, they happen all the time. Yeah, but there are 2 separate quality problems that might be happening on a vehicle. Doesn't mean that they're causal. So I think the answer is basically trusted data is really all about making sure you understand the lineage, the source, you understand the field, what is the definition of the field, how is it calculated, so understanding the business context around data. So as soon as you get data for a new area, sales or inventory or wherever you're working on, just make sure you work with the business unit, business SME, subject matter experts to understand what does each of these mean, how are they collected, how are they calculated, which ones are captured fields, which ones are manually calculated fields, so that you can do that feature engineering, right? And then when you are building the model, then it's all about, if you have, statistical models, you can do probabilistic modeling. Or if you're doing machine learning, deep learning, it's hard to explain because the model just gives you result. Then you really need to bank on your test and training data set. And then make sure that your input data is normalized, right? The example I showed you around safety stock, you can give it a skewed input because your demand is always kind of skewed, instead of running that 500 simulations, like to give it a normalized input, and you will get a skewed safety stock. So how do you really understand is your data represents the actual population that you're feeding in, or does your data have bias? You got to understand that if your data has bias, then your result will have bias, and that's something as a practitioner you must understand, and validate, and then being able to put your name around an outcome and say, yep, I've done this, and here is the known and here is the unknown, because I don't know everything. I don't know, Vic, I'm sure you want to add something to this, so go ahead.
Yeah, I completely agree with you. It's just not addition, just say it in my own words. Would be like, so we never know if the data is good or bad. So we do have statistics methods to help us to decide whether this is usable, whether this model is usable. As Dr. Abhi just mentioned, there are statistical methods. So that's why we also use training set, validation set. So if this training set and validation set, if those come from the same distribution, so I believe we don't have a lot to worry about, because we never know what's the true distribution of the data. If the data you get have the same distribution as the problem you are solving, so we are settled in a subspace. So that's current status.
Thank you, Vic. So the next question from the participant is to you, Vic. Is basically, how do you evaluate the efficacy of the model on isolating a single voice within a sea of multiple voices in the input data? And if you do that, how do you isolate a single voice? What is the method of isolating single voice?
This is a very, very good question. So actually, we do have this model tested with a bubble noise. We call it bubble noise, so that it's a bunch of people talk behind, just to simulate the real situation that you put the device outside of the world. There's two approaches. One is we do not isolate this single voice. We just rely on the model to generalize to filter out the non-useful information and just capture the useful information. As you probably, if you know that this in the audio, it's very high frequency. For 1 second, you have maybe 16,000 points. So how do you get this useful 200 point information? 200, I'm mentioning the embedding space. Usually 200, 2000, so that's a number we're talking about. So how do you extract those useful information out from this noisy data that rely on the model? So that's one way. The other way is how do you isolate this single voice? So right now we are using this voice biometric to isolate this single voice. So as you do speech, there's a branch of research. It's called speaker verification. So just to match, so whatever you say doesn't matter, but the model will be able to tell whether this is your voice or not. So based on that embedding, the biometric embedding, it can help us to just extract this target user's voice.
Thank you very much. That is really interesting for me to also know and learn. Thank you, Vic. The next question is again to Abhi, and the question is like about the forecasting model, revenue forecasting model. I think your company is fairly large and it's a big company, but the question is how accurate is the model for small companies where the growth dynamics are a bit chaotic, a bit noisy, and it's fluctuating all the time. Can we use forecasting models for those class of problems too?
I think I can tell you that the fluctuation in my revenue forecasting is huge. And that's why we got the problem to begin with. Because I think, and it's not a big company, small company, it's like the overall market dynamic that we live in, right? The world we live in has become a lot more unpredictable overall, right? What used to be 20 years ago, right? It used to be a lot more consistent, 3% year over year. And now things like climate, things like COVID, they or something else, election, there is basically an impact, that external factors are creating on the market. Who knew housing bubble is going to be this bad, that people are paying 10-15% is still like it's like a lottery. You don't know if you're going to win or not, right? So it's I would say it's kind of equally applicable for both large and small companies. It's really about thinking about, no matter if you're large or small, it's understanding your customer base, it's understanding your industry, it's looking and spending time on external indicators. It's not about the size of the number that you're predicting. It's really about understanding the domain and what creates fluctuations in the realm in which you are trying to go sell and apply, and what might be things that are more peripheral that you are not thinking about, and what is the understanding, what's the impact of those things, and then being able to incorporate that into the model effectively. And it's always a learning, it's that model is not done, I will tell you that. There is always a every quarter, every month, when we do a forecast, we understand actuals, we go back and spend time looking at it and how are things performing, what are we missing, how can we take it to the next level. So I don't think it's a means of, the answer is large dollar forecasting or a small dollar forecasting. It's really understanding the markets you serve. I think in a lot of times large dollar forecasting is more complicated because we sell into so many diversified markets. It makes it actually more challenging to predict variations in all of them and how do they balance out and where they don't. If you're in a more concentrated space, it's a lot more reliable, I would say, to predict a growth curve that you are targeting as well as how the markets are behaving.
Thank you, Avi. We are coming very close to 12 o'clock, which is the end time of this webinar. So I would like to take this opportunity to thank our panelists, Abi Seth and Jin, for sharing their valuable time with all the participants in this webinar. And with that, we will conclude this webinar. And as I mentioned at the beginning of the webinar, that next week, Thursday at 11, our webinar will be focused on manufacturing domain, manufacturing analytics. So if you're interested in learning how machine learning, AI, and data science is being used in many different manufacturing problems, please join us next week. With that, I thank you everyone in participating, and I look forward to your participation in the next webinar too. Bye, and have a great day.
Thank you so much. Nice to be here. Yeah.